This lesson joins the two halves of the section together. We have covered devices that put data in and devices that put results out. Sensors and actuators are the pair that let a computer interact with the physical world directly, with no person involved at all. And there is one obstacle to that, which everything else in this lesson works around. Physical properties in the real world, light, heat, pressure, sound, are analog. They are continuous, and they change constantly and by any amount. A microprocessor is a digital device. It only understands ones and zeros, discrete values. Those two things cannot talk to each other directly, so a converter has to sit between them. On the way in, that converter is the ADC, the analog to digital converter, and an ADC is always needed, without exception, because every sensor produces an analog reading and the processor simply cannot accept one. That sentence is a standard mark scheme requirement, so learn it in those words. Data from the sensor is converted to digital using an ADC so that the microprocessor can understand it. On the way out, it is less absolute, and this is worth getting right rather than overclaiming. A DAC, digital to analog converter, is needed only when the actuator requires a varying analog signal. A motor whose speed has to be adjusted needs one, but an actuator that is simply switched on or off, like a buzzer or a heater, can be driven straight from a digital output with no DAC at all. So ADC always DAC when the actuator needs a varying signal. A sensor is an input device that continually measures a physical property and sends the readings to a microprocessor. And I want to stress one word in that definition, because it is where a lot of marks quietly disappear. A sensor measures. That is all it does. It does not decide anything, it does not compare anything against anything, and it cannot switch a device on. A temperature sensor does not know what a comfortable temperature is. It reports a number over and over, and something else decides what that number means. If you write that the sensor turns on the heater when it gets cold, you have given the sensor the microprocessor's job, and that is a mark gone. The syllabus names 14 sensors, and they are all in the table on the page. You do not need to memorize 14 separate mechanisms. What you need is to know what each one measures, because exam questions describe a scenario and expect you to pick the right sensor. Temperature measures how hot or cold something is. Heating systems, ovens, greenhouses, car engines. Light measures the intensity of light falling on it. Automatic streetlights, phone screen brightness. Pressure measures force applied to a surface, electronic scales, security mats, tire monitors. Proximity measures how close an object is, car parking sensors and automatic doors. Infrared detects infrared radiation or a broken infrared beam, which is how burglar alarms and motion detectors work. Humidity measures water vapor in the air. Moisture measures water content in soil or a material, which is what automatic irrigation uses. pH measures acidity or alkalinity for soil monitoring and swimming pools. Gas detects the presence or concentration of a particular gas, a carbon monoxide alarm. Flow measures the rate a liquid or gas is moving, water meters and medical ventilators. Level measures the depth of a liquid in a fuel tank or a washing machine. Magnetic field detects a magnetic field, which is how a door contact in an alarm system knows the door has opened. Acoustic detects sound or vibration, breaking glass or a leak in a pipe. And an accelerometer measures acceleration and change of tilt, which is what rotates your phone screen and what fires an airbag. An actuator is the other end, an output device that carries out a physical action on the microprocessor's command. If the sensor is how the computer perceives the world, the actuator is how it changes it. Motors create rotational movement. Washing machine drums, robot arms, fans, and the vents in a greenhouse. Valves control the flow of a liquid or gas by opening and closing in irrigation and central heating. Heaters convert electrical energy to heat in thermostats and greenhouses. Buzzers and beepers produce a sound signal, the chime when a microwave finishes, or an alarm. Pumps move a liquid or gas through a system, and lamps provide illumination or a visual warning. Notice how many of those pair naturally with a sensor: a moisture sensor with a pump, a temperature sensor with a heater, a gas sensor with a buzzer. That pairing is usually what a scenario question is really asking you to construct. Which brings us to the part in the middle. The microprocessor is the decision maker, the only component in the system that compares anything. It receives digital data from the ADC. It compares that data against a preset value stored in memory. And if the condition is met, it sends a signal to switch the actuator on or off through a DAC if that actuator needs an analog signal. That phrase preset value is worth having in your vocabulary because questions often award a mark for naming it specifically. It is the target the reading is measured against. But there is a fourth step, and it is the one that turns 3 instructions into an actual control system. The process repeats continuously. Let me run it through with the greenhouse example to show why that matters. Target temperature 25 degrees. First pass, the temperature sensor measures the air and sends an analog reading, say 21 degrees. The ADC converts that reading to digital so the microprocessor can accept it. The microprocessor compares 21 against the stored preset value of 25. 21 is below 25, so it sends a signal to switch the heater on. Now, and this is the whole point, it does not stop. It goes back to the beginning and takes another reading. Second pass, some minutes later, the sensor now reads 27 degrees because the heater did its job and then some. Same ADC conversion, same comparison against the same preset value of 25, but 27 is above 25, so this time the microprocessor switches the heater off and may open a vent using a motor. Identical steps, opposite action, because the reading changed. And then it goes round again, indefinitely. That is what holds the temperature near the target. A system that checked once and stopped would not control anything at all. It would just make one decision and let the greenhouse drift. One distinction that follows naturally from that loop and is worth having straight. A monitoring system takes readings and reports them. It records, displays, or raises an alarm, but it does not change anything. A patient monitor in a hospital showing heart rate is monitoring. A control system takes readings and acts on them to change the physical conditions, which is the greenhouse we just ran. The difference is entirely whether there is an actuator on the end doing something about it. If a question describes a system that only warns a nurse, do not write that it adjusts anything. Nothing in it does. 4 things to take into the exam, and they are all sentences rather than facts. First, always state that data from the sensor is converted to digital using an ADC so the microprocessor can understand it. That is close to a required phrase. Second, say the readings are taken continuously and the process repeats. Describing a single check does not describe a control system, and this is the most commonly dropped mark in the whole topic. Third, keep the jobs separate. The sensor measures and nothing else. The microprocessor compares and decides. The actuator acts. Never let the sensor make the decision. And fourth, name the preset value explicitly as the thing the reading is compared against. Get those 4 into an answer, and there is very little left for an examiner to take away.